All right, everyone, welcome. Today we are stepping into the ring for what you might call a heavyweight bout in the world of programming. In one corner, we've got the systems-level powerhouse Go, and in the other corner, the full-stack champion, TypeScript. We're going to put them to the test, head-to-head, in a pure performance benchmark.
So that brings us to the big question, right? When the rubber really meets the road, in a clash of these modern languages, who actually comes out on top for raw performance? To figure that out, well, we've got to meet our contenders first. So first up, just like in any good title fight, we've got our tale of the tape. Let's get to know our two contenders before the bell rings. You see, at their core, these two languages are designed with totally different philosophies. Go is a compiled language, which means it gets translated directly into machine code before it runs. You can think of it like it's got its battle plan completely memorized ahead of time. TypeScript, on the other hand, gets transpiled into JavaScript and then runs on the Node.js runtime. And for handling lots of tasks at once, Go uses something called goroutines. These are super lightweight threads. TypeScript, well, it uses the classic single-threaded event loop. And trust me, this fundamental difference is going to be the key to understanding all the results we're about to see.
Okay, so we've sized up our contenders. Now it's time to set the stage. To make this a fair fight, we have to lay down the rules of the gauntlet. That's our benchmark methodology.
So just to make sure we're all on the same page here, what exactly is a performance benchmark? Well, it's pretty simple. It's just a series of standardized tests. We're going to run the exact same tasks on both languages so we can get a direct apples-to-apples comparison of how they do under very specific conditions.
Our gauntlet today is going to have 3 distinct rounds. First up, a CPU-intensive task. This is all about raw number crunching power. Then, for round 2, we've got a memory allocation test to see which language manages its resources more efficiently. And finally, an I/O throughput challenge. This one is absolutely crucial for things like web servers. 3 rounds, 3 different tests of strength.
All right, the rules are set. The contenders are ready. Let's get to the main event, the performance showdown, round by round. Ding, ding, ding. Kicking things off, we have round 1, the CPU-intensive task. This is all about raw processing speed. The question is simple. Who can solve a complex problem the fastest?
And the results are in. Wow! For execution time, remember, lower is better. And, well, just look at that. Go's time is significantly lower. That's a massive lead right out of the gate.
So yeah, the winner of round 1 is, decisively, Go. And honestly, this shouldn't be a huge surprise if you think back to our tale of the tape, because Go is a compiled language. Its code is translated into the processor's native tongue before it even runs. That pre-optimization gives it a gigantic head start for pure number crunching jobs like this one.
Okay, on to round 2, the memory allocation test. See, it's not just about being fast, it's also about being efficient. Who uses the least amount of your system's memory to get the job done?
Looking at peak memory usage, where, again, lower is better, Go comes out ahead, and not by a little. It shows a much leaner profile, using way less memory than TypeScript running over on Node.js. This result really highlights another one of Go's core strengths. Go takes this round because it has this super efficient garbage collector. Plus, it can create these incredibly lean, self-contained programs. The language was just designed from the ground up for this kind of system-level efficiency.
Okay, Go is up 2-0. It's starting to look like a knockout. But hold on, it's not over yet. Welcome to round 3, the I/O throughput challenge. Now this test is critical for modern web apps. It measures how many requests a server can handle every second. And look at this. In what is a pretty stunning turn of events, the results are incredibly close. This time higher is better, and wow! TypeScript running on Node.js actually edges out Go by the absolute slimmest of margins. This is a real nail-biter. We're calling this one a photo finish. So, why was it so close? It's because both languages are absolute champions at this specific kind of task. Go's lightweight goroutines and TypeScript's non-blocking event loop are just different architectural paths to the same goal, handling thousands of connections at once. And it turns out both are incredibly good at it. So, the benchmarks are done. What does all of this actually mean for you? It's time to move from the abstract numbers to the real world. Let's talk about choosing your champion. Which tool is the right one for which job?
So let's break down the final scorecard here. When it comes to CPU-heavy tasks and keeping memory usage low, Go is the undisputed champion, period.
But for I/O-bound tasks, like handling tons of web traffic, it's pretty much a tie. So that's 2 decisive wins and a draw for Go.
So here's the practical takeaway. If you're building a command line tool that's going to crunch a lot of numbers, or a high-performance microservice that needs to be super efficient, Go is your champion. No question. But if you're focused on full-stack development, you need to prototype and move fast, and your main bottleneck is just handling a ton of network requests, TypeScript is an absolutely excellent choice.
But listen, these benchmark numbers, they only tell part of the story. The final and maybe the most important takeaway here actually goes beyond raw performance.
I just love this quote because it really gets to the heart of the matter. Raw performance is one thing, but the best performing language is almost always the one your team already knows best, the one they can use to build and, just as importantly, maintain your app in the most effective way.
And that really leaves us with this final thought to chew on. Performance is absolutely critical, but it's not the only factor. You always have to ask yourself, what's the cost of developer velocity? Because the fastest code in the world doesn't help anyone if it takes your team forever to write and debug it. It's all a trade-off, something to think about. Thanks for tuning in.